Okay, dear student, welcome. We are studying about chapter 12, wave and sound. In the last class, we have discussed about constructive interference. The other type of interference is destructive interference. So, when two waves interact each other at the same point, in the same time, in such a way, the crest of one wave with the trough of other wave meet and produce wave of zero amplitude. In the result is called destructive interference. Mean, look at the diagram. This is one wave and this one is other wave. Both the waves are meeting at the same point in the same time. This one is the crest of one wave and this one is the trough of one wave. Both are meeting at the same point in the same time. So we get zero output. Likewise for the other crest and trough. Mean crest and trough both cancel each other and we get no output. Therefore it is called destructive interference. Now next topic is standing wave or stationary wave. When two waves having same amplitude and frequency but opposite direction interfere each other at the same point in the same time produce a pattern is called standing wave or stationary wave. Look at the diagram. This wave is going towards north, south, and this wave is going towards east. So both interact each other at the same point, but their direction is opposite, frequency and amplitude is same. When both the wave interact each other, they produce a pattern like this, which is not movable. This is standing pattern. Therefore, these are called standing waves. So, standing wave is produced. This wave can also be produced by one source. When one wave is incident and the other wave is reflected wave, both interfere each other because their frequency and amplitude remain same but direction is opposite. When interfere, they produce this pattern. This is a standing pattern. This is not movable pattern. It is known as standing wave or stationary waves. How we will use this standing wave or stationary wave? Uses of stationary wave means, number one, stationary waves are used to study other waves. They are used to analyze other waves. They are used to produce nodes and antinodes. They used to find the properties of the other waves. So these are the simple uses of stationary waves. Now nodes. What is nodes? The points of destructive interference on the stationary wave are called nodes, and the points of constructive interference on the stationary waves are called antinode. Look at the diagram. So this one is one wave and this one is other wave. Both are producing a pattern that is stationary waves, and these are the points. The point that is on mean position, that is node, and the point that is on the extreme position of the wave is antinode. So these are the nodes and antinodes of stationary waves. Now come to the difference between nodes and antinodes. These are the points of destructive interference. Nodes are at mean position, therefore there is no output, zero output. These are the points of constructive interference because they are at extreme position at maximum amplitude, therefore there is maximum output. These are at the mean position, these are at the extreme position. As I have told you before, there is zero output there is maximum output. They are denoted by N and they are denoted by A. So look at the diagram. This one is stationary wave, one part of the stationary wave. So this one is node and this one is antinode. So if you take the distance, that is quarter lambda or 1/4 lambda mean, half this from here to here, node to node is half wavelength and node to antinode is quarter wavelength. Then we say, for learning purpose, you have to learn it that distance between nodes and antinodes is quarter wavelength or 1/4 lambda or lambda by 4. So this is the distance between node and antinode. Okay student, next topic will be sound.